Hello my dear students, how are you all? Welcome back to our YouTube channel Diksha Karnataka. I hope all of you are doing very good. Okay, so today is day 27 of our ongoing series, which is 60 out of 16 KCET mathematics in 100 days, right? So what are we doing today, sir? We are continuing with what? A new chapter, which is integrals. We have done session 1, the part 1 in this chapter, where we talked about indefinite integrals. Okay, we did from the basics formula of integrals that we had for different functions, for trigonometric function, for inverse trigonometric functions, for logarithmic functions, exponential functions. We did some questions from there, okay, and we solved them in the previous session. In today's session, we are starting the first topic, which is the most important topic in the beginning, okay, of what? Indefinite integral. So we are starting with bacha indefinite integral. In this, we'll take what? We'll take the first thing is method of integration. So we'll have various methods of integration, and in today's session we'll talk about only substitution method and solve questions on the substitution method. We'll also see various types of substitution, okay. So it's going to be very important. Why this is important? Because usually and in all examinations that you know, questions will not be simpler, okay. Means they will give you intentionally a difficult question, but once using a smart substitution, if you can make use of a smart substitution, if like you're looking at a question, if it clicks to you that after putting this condition, after putting this substitution becomes, the problem statement will become very easy, then our the time required to solve a question will become much shorter, okay. That's why substitution is very important, not only here but anywhere you're solving questions in mathematics. If you can substitute something and get the answer quicker, good for us, right? So that's why please pay attention to the all substitutions that I'm going to explain you in the session today, okay. Let's begin with the session. I hope all of you are prepared, so get your pen and paper out and let's start with the session, okay. Let's start, okay. So methods of integration, what are these, sir? First one that we are doing today, okay, by substitution. Okay, there are following three methods of finding integrals, okay, by reducing them into standard forms, okay. Integration by substitution, using partial fractions, and using by parts, excuse me. So why we can use a substitution, partial fractions, or by parts. We'll see these two topics in the coming sessions. We'll see those two topics in the coming sessions, but today we are dealing with only this part, bacha, only substitution, okay. So I've taken I think 8 to 9 questions and we'll solve it on substitution, again of different varieties, so that we'll get used to all type of questions in substitution, okay. Let's see how will this work, okay. Now for example, if this type of form is given here, so you know when to use substitution, no, I'll tell you what. There is actually a situation when you can use substitution. That means if something is present in the given question statement or problem statement, then a substitution makes the question easier. How, sir? Let's see how. For example, if I have a function, let's say fx, if I have a function fx, okay, and the derivative of this function, which will be called as what? F dash of x, okay. Example, I take function as y equals to ln x, okay, y equals to ln x, and what is the derivative of this function y dash? 1 by x, sir, 1 by x. If both of them are present in the same function, okay, under the integrals, so basically if the integral goes as f of x multiplied with f dash of x, and what will be there, bacha? You'll have a integrating variable which is going to be dx. If the condition is like this, function is there, function's derivative is also there with dx, okay, then I can substitute this fx as something else. For example, if I have ln x and 1 by x present in the question, if I have ln x present with 1 by x, for example like this, ln x upon x dx, okay, under the integration, what I can do, I can write it as integration of ln x, and this will be what? Simply dt. So if you want, I can write it as simply what, bacha? T. I'll show you how. So let me show you all the steps. So okay, so this was the question here. Both function and its derivative is present in the question. You can see here ln x is there, and derivative of ln x is what? 1 by x is also there. Then what can I do? What can I do is, please have a look, I can take substitution as t equals to ln x, okay. Then what is my derivative? Simply my dt will be what, bacha? 1 by x dx, okay, 1 by x dx. So I can take this part and rewrite this as what, bacha? I can write this as, please look at here, I'll erase this extra information, okay, I'll erase this. So I can write this question as, I'm taking one example and solving it for you. I can write this integration as integration of, what is my ln x? Sir, t. I've taken substitution, right? ln x is t. So I can write this ln x as t and check here dx by x. How much is that? Dx by x. Simply dt. Simply dt. Now check this integration. Is it simpler to integrate than this or not? I have to integrate ln of x by x. And what is this? Integration of t. This is simple, right? What is this answer? Sir, t square upon 2 plus c. Sir, t square upon 2 plus c. What is t value? Simply ln x the whole square upon 2 plus c. ln x the whole square upon 2 plus c. Now this is easier to find from here, right? So that's why in some questions after substitution, not some questions, whenever we take substitution, actually the problem solving becomes much easier. Okay, so you see here from the statement the function is present, also the function derivative is also present here. See, phi x is there and phi dash x is also there. In that case I can take this phi x as t. I can take phi x as t, phi x as t, or another variable p, y, anything I can take t. And if I take this will be what? Simply what? Dt, simply dt. Okay, then what will happen? This function will become, this function will look like what? Integral of f of t dt. Please have a look. I took phi x. I took what, bacha? Phi x equals to t. Yes or no? Then what is this going to be? F of t, and if you differentiate t, you'll get what? Phi dash x equals to phi dash x dx equals to dt. So what is the new integration? Integration of ft dt. How? We solve with the example over here. Now let's look at some standard forms. So whenever we have a question in this integration forms, 1, 2, 3 and 4, whenever we have this kind of situations, what is my substitution going to be? So I said no, we'll take different varieties of questions and or categories of questions, and we'll check the substitution for each of them. So for the first one, whenever I have f of ax plus b, okay, whenever I have this type of integral, simply take ax plus b equals to t. Simply take ax plus b. So what will this become? Please check here. If you have to show you this, check this. Differentiate this part. I'll have only a left because x will be what? X will be simply 1. This will be 0. Okay, multiplied with dx. What will I have? Dt. Okay, what I get? So I get a dx equals to dt. What I get dx as? Dx equals to dt upon a. Yes or no? Please check. So I took this as ax plus b as t. Think about it. If I'm taking a substitution of ax plus b as t, I have to change all the variables. No, wherever is x, I have to change the variable. So this is going to be in terms of t, and I have to change dx also. So what is my dx now? dt by a. I have taken the differentiation of this statement, dt by a. Now change this integration. How will this look like? It will become integral of f of, tell me bacha, f of t, sir, because ax plus b is t, so f of t. And next what is dx? So dt by a. dt by a. I can take this a out because it's a constant. Now this becomes ft dt. Whatever is the function, this is going to be easier to integrate than this. This will be easier to integrate. Okay, so I've explained you how this will work out. Why? How will the substitution, means after using substitution, how will my integral look like? So this is the transformation in the integral. Yes, after taking from here substitution, this is how the integral will look like using the substitution. Okay, next, this is same thing, right, as the statement. F of phi of x, phi dash of x is also there. Take phi x equals to t. What if there is a ratio like this? Okay, I took this question, in the ratio also was there, ln x upon x was there. So whenever you have it in ratio, again you take what? Fx as t. So whether it is function of a composite, okay, function of a function, or in the rational function also, you take fx as t. Over here also, function, okay, to the power n. Function to the power n is there. This is power, right? This is power n. I get it as function dash of, means derivative of the function, then x. Again, what are you going to do? You're going to take f of x t. What will this become? Please check. It will become t power n dt. T power n dt. Simple to solve, right? This is simple to solve. Simply what are you going to get the answer as? T power n plus 1 upon n plus 1 plus c, right? Then you can substitute back this as f of x power n plus 1 upon n plus 1. Okay, so after doing this substitution, the problem statement is becoming simpler or easier for us to solve. Moving on. Okay, now these integrations, when I was giving you some formulas in the previous situation, I skipped some integration formula. So this is the 4 very important, rarely asked, they don't ask it those many times, but again very important. Okay, integral of tan x dx, integral of cot x dx, integral of secant x dx, integral of cosec x dx. Okay, what is it? For tan x we get log of mod of sec x. Okay, log of mod of sec x. Why, sir? Why we are doing mod here, bacha, in log? Any idea? Any idea? Okay, sec x can have value negative also, right? Sec x can have a value negative also, but log cannot have that. Please check. Log is either this or this. Is there a negative x? Can you define log for a negative x? No, sir. That's why the model is. That's why wherever you see log, no, you can find a model is there. Okay, no confusion. You can avoid that also. Don't have to write it. Just understand this. Keep this in your mind. Log cannot operate on a negative value. For that reason, x is always positive. You cannot define the logarithm for this. So only condition is x greater than 0. For x less than 0, there is no log function. You cannot define the logarithms. The boundary condition is x greater than 0. Okay, the domain is like this. For that reason, the modulus is present. I hope this is clear. Okay, chaliye. Let's see the formulas now. We'll break and verify how this is true. Can we do it? Can we do it? Of course, sir. Let's see. If I differentiate log of sec x, just if I do for the first one, I get what? Differentiation of this will be what, bacha? 1 upon sec x, and what? What is the differentiation of sec x? Sir, sec x times tan x, right? Yes or no? Yes? Goes out, right? Yes or no? Okay, and this c will become what? Simply 0. So if I differentiate RHS, I am getting what? LHS, right? Please check. If I differentiate RHS, I get LHS. Verified. Integration of cot x, again you can do the same way. You will get 1 by sin x. Please check. You will get 1 by sin x times cos x. How much is that? Cos by sin, cot x. Okay, same way you can do for this also. Differentiation of log of secant x plus tan x. I'll do for the third one also. Okay, let's see the verification of this. What will this be? Simply 1 upon sec x plus tan x, and differentiate this. What will this be, bacha? Sec x tan x. Chain rule we are doing, right? For sec x it is sec x tan x, and for tan x it is going to be sec square x. For x we have 0. For sorry, not x, for c. For this c we have 0. For sec x we have sec x tan x. For tan x we have sec square x. Okay, take sec x common here in the numerator. Sec x is common, sir. It will become tan x plus sec x. What is divided by? Whole thing. 1 times of this is there. Sec x plus tan x. Please check here. Gets cancelled. What is my answer? Simply sec x. So if I am differentiating the RHS, I am getting what, bacha? LHS sec x. Okay. So basically, integration of tan x is log of sec x. Cot x is log of sin x. Integration of sec x is log of sec x plus tan x, and integration of cosec x is log of cosec x minus cot x. Again, c will be there for all of it because it is constant of integration. Yes, chaliye. Okay, verified. Now let's look at some substitution. Means in this case of, means whenever we have, again related with only what? Trigonometric substitution. Okay, whenever we have these root conditions in the question, whenever we have this type of situation present in the question and we are asked to find what? Integration. If you use this substitution, no, for x, the problem will become simpler. I'll show you how. Okay, I'll try to explain you for maximum number of them. Let's see. If I write, because others will be very simple as the same way. So let me show you. Y sin theta, sir. Why x equals to a sin theta? The statement is, if in the integration we have this condition, in root of a square minus x square, we have root of a square minus x square. Okay, so if you substitute this, bacha, a sin theta here, what will have happened? It will become what? Tell me. It will become a square minus a square sin square theta. Yes or no? I can take a square common. It will become what? It will come outside as a. Correct, na? I can take a square common and bring outside to the root. Will come as a. I'll have over here is 1 minus sine square theta. What will this become? A times of cos square theta in the root. How much is this? Simply a cos theta. Yes or no? So I got rid of this statement by substituting x equals to a sine theta. Same way, if you substitute a cos theta, what are you going to get? What are you going to get? You'll get it as a sine theta over here. Okay. And one more reason is there. Sometime what will happen? Another reason is there. If you take here, if you take a square, no, see what is happening. Okay. Yeah. So like this. Again, if you remember, this is a differentiation of 1 minus x square. No. If I have sine inverse, let's say. Okay. What is the differentiation of this? 1 minus x square. Okay. So the same format is also there. So this is how you can identify what to substitute. See this? 1 minus x square is there. Same way for cos inverse, what is it? Simply minus 1. So you can relate with that way. Relate with that way. But the reason is this, what I wrote here. Because identity will be applied. What will happen? Identity will be applied, bacha. Okay. Let me show you this. So basically, I will not write all the statement. I'll write it that what is going to be transformation. My transformation will be simply what? Please check here. Simply what? It will become a cos theta. Okay. If you take a sine theta, no. If you take x equals to a sine theta, okay, this whole thing will transform into a cos theta, okay, or vice versa. If you take a cos theta, it will become a sine theta, okay. What about this? What about this? Please check. If you put a tan square theta, what is the identity? If you remember, 1 plus tan square is sec square theta. If you put here a tan theta, it will become a square tan square theta. You can take a square common, it will become what? A square times of this. So a square sec square theta. What is the result? What's the result of this? Simply a sec theta. Okay. So basically we are trying to get rid of this form using the substitution. Okay. Using the substitution. Okay. Same goes with over here also, whether in the root or not. Okay. Same here. What about this? You'll get it as sec theta and cosec theta. Why, sir? If you take 1 on that side, it will become what? It will become sec square theta minus 1 equals to tan square theta or not? Okay. So if you put this as a sec theta, what will happen? Check here. A sec theta will become what? A square sec square theta. Take a square common, it will become what? A square times of sec square theta minus 1 will be what? Tan square theta. Again, you can take it out that. This will come out as a tan theta. A square tan square theta will, in the root you will have a square tan square theta. What is going to come out? A tan theta. It will come out as a tan theta, sir. Okay. Let's see. Let's see. Okay. Again over here cos 2 theta. Why I am doing this as cos 2 theta, sir? Please check here. If you do that, you're going to get what? If I take this as cos 2 theta, I'll get it as a minus a cos 2 theta. Right or not? Take this a common. Okay. And over here also a plus a cos 2 theta. Okay. If you take this, take a common. What is left here? 1 minus cos 2 theta and 1 plus cos 2 theta. Yes or no? This whole thing is in the root. Yes or no? Yes or no? Yes. So if you see here, 1 minus cos 2 theta is what? It's going to be 2 sine square theta. Okay. And what is this going to be? 2 cos square theta. Okay. I can get rid of this root, and what is the result going to be? It's going to be simply tan theta. Tan theta? Yeah, tan theta. Correct. This is going to be tan theta. So after applying this condition, I get it as tan theta. And if you use it over here, it will become what? Cot theta. How, sir? You want to see? I'll show you here. If it is complicated, I can show you here. So use this condition. A minus a cos 2 theta. And what is this? A plus a cos 2 theta. In the root, right? Take a common, bacha. 1 minus cos 2 theta upon 1 plus a common. Okay. Take the root. A and a goes out. Right? What is this going to be? Tell me. It's going to be 2 sine square theta. How, sir? Formula of cos 2 theta. What is the formula of cos 2 theta? Please check here. 2 cos square theta minus 1 or 1 minus 2 sine square theta. Yes or no? Yes or no, right? So this is going to be what? If I use this and this, I'll get what? 1 minus cos theta will be what? 2 sine square theta. Same thing I've written here. 2 sine square theta. And this will be what? 2 cos square theta. Cancel. What is this? Tan square theta. And what is this? Tan theta. Can you see that? Can you see that? So what you're doing, what I'm doing here, no, I'm trying to explain you why this substitution, okay, because usually I can say just, sir, for this condition, use this substitution, for this condition, use the substitution, okay, but that is not enough for a student, no. The reason is why. So the question that comes to your mind is, sir, why only this? Why for this situation, why only the substitution? Why not others? That's the reason, bacha. Because if you use the substitution, no, the root will be eliminated and you'll have a simpler problem statement, okay. Chaliye, same way you can do for x equals to a sin square theta over here, okay, because this will become what? Check here, will become a sin square theta, okay, and will become what? A cos square theta. A and a will cancel, will become cot theta, okay. This is sin square, it will become tan theta. This will become again, what is it? It will become cot theta. So we'll see whatever we are substituting. So you can test from your side. So this is going, what I'm asking is, try from your side. Try this, okay. Verify this. Verify what you're getting for this one and for this one. Try this one. Please try. Same way, this also you try. Put tan. Why tan, sir? Same identity. So this also you try from your end, okay, and from this also you try. Try to check all the three. Last three you check and let me know. Okay, that's yes, sir. I got rid of the root and I got a simpler problem statement whenever I'm using this substitution. I hope this is simple. I hope this is simple. Okay. If you want, I can show you the last one. Okay. This two you try. This one I can show you. Okay. What is it going to be? Let me see. A minus x, x minus b. Okay. A minus x, x minus b. How will this be? You substitute here x as a tan square theta or a cot square theta. Substitute it here. I'll take this, a minus x and x minus b. What I'm taking x as, bacha, what is my x? A tan square theta. Let's take a tan square theta. Yes, I can do what? Again substitute it as x equals to a sin square theta. Okay, so let me try it here. What will this be? Please check. Please check here. X equals to a sin square theta. Yes or no? Yes. Okay, what is the condition? X upon 1 minus x. X upon a minus x. Is this right, bacha? Is it right? Please check. X upon a minus x. Okay, substitute this as x equals to a sin square theta. What will happen? A and a will cancel, sir. Okay, please check here. A sin square theta in the numerator. A minus a sin square theta. What will this be? Please check. A sin square theta upon a, you take common 1 minus sin square theta, right? And all this be a sin square theta upon a cos square theta. Check here, a and a goes out. How much is that? Tan square theta. Okay, how much is this? Tan theta. Okay, it is how much? Tan theta. Yes, sir. Okay. All right. So this will get it as this will get it as tan theta. Okay. How much you'll get? You get it as tan theta, sir. Okay. Same way you can do for other also. So please try. Please try from your side, these two, try from your side, do the substitution and make use of the, you'll see how we use in the questions, okay. In not only today's session, in all the sessions we'll use the substitution only, right. So a lot of the questions will be based on this condition, substitution, okay. Chaliye, moving on. First problem of the day. Evaluate x times of 1 minus x 23 power 23 dx, okay. How will you solve this? So this makes it difficult. How can I solve this question? If I don't use substitution, I have to use what? Expansion here. Can I use expansion? Or I can use this, again product tool is there. So we'll, instead of what? Instead of that, I can use the substitution here. Let's see how the substitution will look like. Take this. 1 minus x equals to what? Let's say t. 1 minus x is t. Differentiate it. So we'll get what? We'll get minus 1 times dx equals to dt. Yes, so basically I can write dx as minus dt. Yes or no? Yes. Now what is this? If 1 minus x is nothing but t, then what is my x value? 1 minus t or not? I'll bring this t over here. If 1 minus x is t, my substitution, then x is going to be 1 minus t. I need that here. Please check. For this x, 1 minus t. For this part, 1 minus x, t to the power 23. And what is dx? Substitution is over. Take the minus sign in the front. Minus integration of 1 minus t times t to the power 23 dt. use the expansion here, what are you going to get? Integration of t power 23 minus t power 24, correct, dt. Yes, no, t is there, so t power 1 is there, no, then 1 plus 23 we have to do in the multiplication, whole thing with dt. What is this integration going to be? Minus sign t power 24 upon 24, and this is going to be minus t power 25 upon 25 plus c. This is my answer. Okay, this is my answer. All right, integration will be what? N, x to the power n is there, n plus 1 upon x to the power n plus 1 upon n plus 1. Same thing is here. This is my final answer. This is my integrand. My final answer, sir. Please check. This is my final integration. Okay, moving on. Question number 2. Cot x upon ln sin x. Okay, so if you see here, ln sin x means I can take no, because even in cot x I will have sin x in the denominator only. So yes, let's see. I think this will make sense. So take the ln sin x, which is making our life difficult right now, as the substitution as t. Do the differentiation to find the dx value. How will you do it? 1 upon sin x, 1 upon sin x, and what will this become? Tell me. 1 upon sin x is done. For sin x I have to do again chain rule. Okay, this will be what? Minus cos x, dx will come and dt will come. Okay, so I want to find the value of dx, right? Okay, but I can simplify this. Cos x sin x, what will this be? Cot x with a minus sign is there, I'll take minus on the other side, minus dt. Please check here. So my cot x dx can be replaced by minus dt. I have a cot x dx. Please check here. This integration will transform into what is it? Minus dt, and what is this going to be? Simply t. Please check. Log sin x is t, taken like this. So take the minus sign outside. dt by t will be what, bacha? Minus ln t. And how much is that going to be? Minus log of, or ln of, ln sin x. Okay, I have to, if you want I can remove this, because yeah, no, let's keep it anyway. So ln mod ln, so ln of mod of sin x, okay, plus c will come. So basically, if you want, don't write this modulus, answer can be written as this also, minus ln sin x plus c. Okay, means ln sin x, the ln means take the natural log on ln sin x. This is my answer, because what is the t value? T value is ln sin x. Simple enough. Okay, chaliye. Question number 3. Cosec square x upon 1 plus cot x. Cosec square x upon 1 plus cot x. Okay, how will I solve this, bacha? How will I solve this? Please see here. So this is so simple again. 1 plus cot x I can take it as what, sir? 1 plus cot x will be what, bacha? T. Take the differentiation of this, okay, to find the dx value. 0 plus, what is this going to be? Minus cosec square x, okay, dx equals to dt. So what is this going to be? Cosec square x dx will be minus dt, okay, minus dt. Yes, put it here. Integration will become what? Minus sign dt upon t. Yes or no? dt upon t. How much is that? ln t plus c with a minus sign. Okay, how much is this? ln t means what? ln of 1 plus cot x plus c with a minus sign. Yes or no? Yes, this is my answer. This is my integration. Yes, simple. Okay, moving on. What is next? dx upon ex plus e power minus x plus 2. You have to integrate this. Okay, I have to see the substitution right now. But the thing is, when we take substitution, whenever we have the differentiation of this thing present in the numerator, okay, or some place in the function, but it is not present here right now directly, then we have to use we have to make use of something over here, we have to transform this given function. What is that? This part. Okay, let's transform it. How can we do it? Let's have a look over here. So I get this as, I can write this e power x plus e power minus x plus 2. This is in denominator, right? Upon, so I'll write it as 1 upon this. I will not write dx, this write 1 upon this. So check this out. So 1 upon e power x plus 1 upon e power x plus 2. Please check, please check. E power minus x is there, so I can write it as 1 upon e power x, no problem. My second step is this. Third step will be, I can take LCM now in the denominator. E power x. What will this become? I have to multiply e power x to e power x. It will become e power 2x. Please understand. LCM is what? This is 1, no? This also is 1. So LCM is e power x. I have to multiply e power x to e power x. Will become e power 2x plus 1. And this will be what, bacha? Plus 2 times of e power x. Correct? So now I can take this e power x in the numerator. Yes. So what will this become? Please check here. This will become e power x upon e power 2x plus 1 plus 2 times of e power x. Yes or no? Please check. Same thing is there here. Now if you see closely, very very closely, check here. This is nothing but e power x the whole square. I am writing this here, and this can be written as 1 the whole square, and this I can write it as 2 times of e power x times of 1. Any formula coming up? Please check. A square b square 2ab. Please check. A square e power x the whole square is e power 2x, b square plus 2ab. So I can write in place of this thing e power x plus 1 the whole square or not. Yes. So this whole thing will become what? This whole thing will become basically e power x upon e power x plus 1 the whole square. So after transforming this was the given condition, given question in the function. In the function in the given question, I transformed into this way, e power x upon e power x plus 1 the whole square. Now let's see what we can do. Okay, I'll rewrite this question over here. Integration of e power x upon e power x plus 1, right? New equation. How can we substitute now? Please check. If I take this as substitution, so what I'm saying is, take this t equals to e power x plus 1. Okay, what will this be? dt equals to, what is going to be? E power x plus 0, because e power x differentiation is e power x. And what will be this with dx? I'll write over here. So I hope you know how we're getting dx, right? Because we are doing here dt by dx, okay? And this is then multiplied over that side. If you're not getting it, if you're not, I thought you will understand, but if not, then please don't mind. How will I differentiate t? dt by dx, right? Then I can take this as dx on the other side. It will become what? dt equals to e power x times dx. Okay, that's how I'm getting dx on the other sides every time. So I can replace this by integration of dt upon, this whole square is there. Okay, I think whole square is there. Yeah, e power x plus 1 the whole square is there. So whole square. What is this going to be? T to the power minus 2 plus 1 upon minus 2 plus 1 plus c. How much is this going to be? T to the power minus 1 upon minus 1 plus c. How much is going to be? Minus 1 upon t plus c. How much is going to be? Minus 1 upon, what is my t value? E power x plus 1 plus c. Any option like this, please check. Minus 1 upon e power x plus 1. Yes. Yes. Yeah. Okay. This is my final integration. Final integration is minus 1 upon e power x plus 1, sir. Okay. Moving on. Integration of sine 2x upon sine square x plus 2 cos square x. We have 4 options been given here. Okay. I have to use something here. Please check. I have to use here some formula. Sine 2x is there, right? So I have to use something over here. How can I use it? Please have a look. Please have a look. I can write this as, I have to transform something. The denominator I am writing integration of sine 2x upon sine square x plus what, bacha? Cos square x plus cos square x I can write or not? Please check. How, sir? It's 2 cos square x. It's 2 cos square x. I'm writing individually. This will become what? 1. So I can write this as, what is sin 2x? Simply 2 sin x cos x. Yes. What is this going to be? Please check. 1 plus cos square x dx. Now the substitution. Please have a look. T equals to, I'll take 1 plus cos square x. Now check here. dt by dx. dt by dx will be what, bacha? 0, right? 2 cos x. Now the chain rule will come with the minus sign. Cos x differentiation is minus sign. What is the answer? Minus 2 sin x and cos x multiplied with dx. Multiply this with dx. What I'm getting this as dt. So do I have this? 2 sin x cos x is there. So I can replace this by minus dt. So this will become what? Please check, this will become what? Integration of minus dt upon t. Right? We have taken 1 plus cos square x as t. So what is this going to be? Integration of, sorry, this will become simply I equals to minus log of t plus c. Okay, right? So I equals to what? Minus log of, what is my c? What is my t value? 1 plus cos square x. Please have a look. I've taken t like this, 1 plus cos square x, differentiation with respect to x to get this as minus 2 sin x cos x. I've taken dx on the other side, becomes dx over here. dt is equals to minus 2 sin x cos x with dt, sorry, with dx. Replace this part over here by what? Minus dt. Okay, then this is simply log of t. T value is this thing, option number C. Option number C, bacha. Simple, very simple. Moving on. Okay. Okay. Now minus 1 minus tan x upon 1 plus tan x. Okay. Now you check here in the option they have given only terms of cos and sine. So blindly what you do, convert everything in terms of cos and sine. So what is it? 1 minus sin x by cos x upon 1 plus sin x upon cos x, and this is dx is there. Why like this, sir? Because question is tan x, no, but answer is given in terms of sin x and cos x. One tan x is here, but still, let's see. Mostly sin x and cos x answers are given in the form of options. So take LCM here. Integration will become what? Cos x minus sin x. This thing by what? Cos x, the numerator part, and over here will become cos x plus sin x. Please check here. Cos x plus sin x upon cos x dx. Okay, goes out. Okay, what I've left now? I'm left with cos x minus sin x upon cos x plus sin x dx. Cos x plus sin x dx. Okay, Achha, I have taken the basics, very basics questions on the substitution. The questions will come of different category in the coming classes. Don't worry about that. Okay, if you're finding it easy, good for us, very good for us. Take this as T, because I will not rush into this chapter. Very important, high weightage, right? Very important and high weightage chapter. So we will take it, will take some time, but we will make sure that we are thorough with every single concept or every single topic and questions in this chapter. Okay, whatever the best we can do, we'll do it in the sessions. So sin x equals to what? T. Check this as T. What is it going to be? Minus sin x, differentiation will be minus sin x. Over here I'll have plus cos x. Over here I'll have dt by dx. Bring this over here. I get what? This is my x. Okay. This is not alpha. This is my x only. What I'm getting over here, please check. I'm getting cos x minus sin x. How, sir? Cos x minus sin x times dx equals to dt. Yes, okay. Is this present over here? Yes, sir. So I can write this as integration of dt upon t, right? How much is that? Integration of dt upon t is nothing but ln t plus c. How much is that? How much is that? ln, what is it? Cos x plus sin x plus c. That's the question. I taken t as cos x plus sin x. Okay. Option number A. Option number A. What is my answer? Please have a look. I hope this is visible. Have a look. ln cos x plus sin x plus c. Okay. Any problem? Any problem? If there is, comment and let me know. Comment and let me know about this question, sir. Okay. Now, again a question similar to ln x only. So, usually whenever we have a denominator in the integration, no, most of the time we use either ln x or we use that formula, this one, x to the power n integration. Okay. Either of these we use. Okay. Or we use the special substitution if it is in the form of logarithms. If it is, sorry, trigonometric functions. We use the special substitution that I showed you there, but rarely. Okay. All right. Integration of ln x to the power n upon x. This is the example I took similar to this. Okay, I took it as ln x upon x, but similar to this I took. So what we're gonna do, I hope you know by now. Okay, take simply ln x equals to t. Differentiate it, please. You'll get 1 upon x equals to dt upon dx. What are you gonna get? dt equals to dx upon x. Dx upon x. Transform this integration. You'll get over here as integration of t power n dt. T power n dt. Why? Because this will make what? This will make dx by x will make dt from here. Okay, and this is t. So what is going to be? T power n plus 1 upon n plus 1 plus c. Right? So what is my integration going to be? Final answer. T value is ln x. So ln x to the power n plus 1 upon n plus 1 plus c. Any option like this? Okay. Correct. ln x power n plus 1 upon n plus 1 plus c. Okay. Option number A is correct. Okay. 8th one, e power x 1 plus x sine of x e power x dx. I think this is the last problem of the day. Okay. Very good question. It's a very good question for the substitution. Okay. You can, if this question comes, it'll take time to solve, okay, because it will have multiple applications. You'll see how. Okay. So first of all, we have to figure it out what we can take a substitution. So see, you can see here log is operating on some trigonometric function. Obviously, I have to take x power ex only. Why, sir? Because it has to be 1 upon sine t. It will become what? Log of that function. Something like that will come. We'll see that later. But 1 upon sine is there. So it will be a trigonometric function only of some sort. So I'll take x e power x as t. Let's see what it gives us. What it gives us, x e power x as t. What will be x bacha? What are we going to do for differentiation over here? Any idea? Yes, sir. We'll take it as dt by dx equals to, I have to use what? Product rule. So take for x as 1 and e power x remain as it is. Excuse me. And take x as it is. And e power x differentiation is e power x only. So take e power x common now. 1 plus x. Okay. Dt by dx. What is this going to be? Dt is going to be e power x 1 plus x dx. E power x 1 plus x dx. Anything is there like that? Yes, sir. E power x 1 plus x dx is there. We can substitute that as dt. So transform this integration. This will become what? Dt by sine t. So simply the answer is log sine t. But if you check here, if you write it as log sine t, it will become what? Log of sine of x e power x. Check any place, there's nowhere x e power x. It's always by 2 is there. By 2 is there. It means some type of transformation we have to make to the function, which is not done yet. Okay, we have to do it in this thing. What we can do in this thing? Only thing that I can see here is I write it as cosec t dt. Cosec t dt. Because 1 by sine will become cosec t dt. Okay, sir. What is the integration of cosec t dt? If you remember, today only we discussed. It was what? Log of what? Log of cosec t minus cot t plus c will be there. Plus c will be there. Okay. Now let's see what we can do over here. What we can make of this. So I can take 1 by sine. So log of 1 by sin t minus cos t by sin t, yes, okay, plus c. If I take LCM, what I'm going to get? Please check here. You'll get, this is my integration final answer, log of, not final answer, means this is going to be the final expression. If I simplify this, log of, if I get it like this, 1 minus cos t upon sin t, right, after taking LCM, plus c, okay. Please check. 1 minus cos t upon sin t plus c. But again, options are, none of the options are like this. I have to transform it more, okay. Let's check. Log of 1 minus cos t is what? Remember, 1 plus cos t was 2 cos square t by 2. So 1 minus cos t will be, please check here, cos 2t is what? Cos 2t is what? 2 cos square t minus 1 or 1 minus 2 sin square t. Okay, so cos t will be what? 1 minus 2 sin square t by 2. Yes or no? Yes. Bring this over here and this over here. You'll get what? 2 sin square t by 2 equals to 1 minus cos t. Yes or no? What is this? Same thing is here. So write it here. 2 sin square t by 2 upon what? This will become simply 2 sin t by 2 and cos t by 2. Please check. Plus c. Yes or no? Yes. Okay. Is it visible? Everything is written properly or not? Let me just rewrite these few things. Okay. This statement especially, because angles are important. So I'll write it as 2 sin square t by 2, okay, divided by what, bacha? 2 sin t by 2 times cos t by 2. Yes. Now let's check. 2 and 2 gone. This sin t by 2 will cancel. The extra sin t by 2 over here. What is left now? Log of what? Sin t by 2 upon cos t by 2 plus c. So what this will be? Log of tan t by 2, right? Tan t by 2 plus c. So my final answer, I will be what? Log of tan, what is t? X e x. So x e power x by 2 plus c. X e x power, x e power x upon 2 plus c. Any option like this? Only one is as such. Option number B. Please have a look. So what we did? We took x times of e power x as my substitution, which is equal to t. Got the value of dt from there. Substituted in the expression. Sin t will not work, log sin t will not work for the given options, okay. It's not incorrect, but for the given option it will not work. So I took it as cosec t. Integration of cosec t is log of cosec t minus cot t, okay. From there all of this is substitution using the formulas of identities from trigonometry, okay. So I hope this was it. This was okay, okay. So we have completed the very simple questions on this particular topic, which is substitution problems. Again, we'll take more advanced questions in the coming sessions. We'll take other methods of solving integration as well. First one was using substitution method. We'll have by parts, we'll have by partial fraction. All of this will come. But again, this is very important. Out of all the others, I find two of them, by parts and by substitution, the most important question, because it will be used everywhere, okay. Even if it is not applied over here directly, some other question, when the more than one concept is clubbed together in competitive examination, by parts and the substitution method becomes very handy. Substitution method is used to different cases also. We use it to make our statement anywhere. I particularly use this to make the statement of the problem easier for me, okay. So very important. This whole series for the integration will be very important, bacha. So make sure that you are solving all the questions that I'm doing, every question that I am doing, okay. I'll keep coming with the sessions just for questions, because we are writing a competitive examination. By theory we will not get everything done, okay. Theory is important, I understand, concept is also important, but what is the most important thing? Practice. So I will be coming up with just a session for only question solving. I'll take few questions, 15 questions, 10 questions, whatever I'm going to take, and solve it for a session. So in integration I will have no tolerance. You'll have to solve the questions, no exceptions. You have to solve, you have to solve, you have to solve. You have very less time left. How many? 4 5 months is left. Okay, boards is also there right now. Midterm is going on. So all of this, different roles that you have to fulfill. Being a midterm student, being a board student, then how will you compare for have time for all of this? So whenever you are watching the video, watch and solve all the questions with me. Okay. With this note, I will complete and end the session today. Keep working hard. Have positivity around you. See you in the next session. Take care. Bye bye.